Welcome Arithmetic Ninjas to adding and subtracting fractions with different denominators. But this time we may have to change both denominators, so these are the tough ones. So let's have a look at question number 1. We've got a denominator of 4 and a denominator of 6. Now there's nothing easy we can do to change the 4 into 6. We can't just double 4 because it doesn't give us 6. We can't triple 4 because it doesn't give us 6. So we're looking for a number to be a common denominator that both 4 and 6 go into. So 4 and 6 both go into 24. You could just times the denominators together to make a common denominator. 4 times 6 gives you 24. But also 4 and 6 both go into 12. So we can either use 24 or 12. It doesn't matter, we'll get the same answer or we'd get an equivalent answer at the end, which would both be right. So we're actually going to look at this question twice. Let's look at using the 12 first because that's a slightly better answer. It's better to go with a lower number. Keeps it easier for yourself. So if you turn them both into 12, you've got to decide how you're actually turning them both into 12s. Or to get from 4 to 12, you're doing times 3. So you would do 1 times 3. And 1 times 3 is 3. So that's 3 12s. And to get from 6 to 12, you're timesing by 2. So you need to do the 0 on the top, so that's 1 times 2, which is 2 12s. So we're basically dealing with 1/4 has now become 3 12s, and 1/6 has now become 2 12s. So we no longer really need the original fractions. We've made a new question, 3 12s plus 2 12s. Now you've got the denominators the same. You can just say 3 cars plus 2 cars is 5 cars, where the unit is cars. So 3 12s plus 2 12s is 5 12s, where the unit is 12s. If you were to do it with 24ths, you'd still get the same answer. So if we go for 24ths, we'll see that to get from 4 to 24 is times 6. So you do 1 times 6, which is 6 24ths. To get from 6 to 24 is times 4. So you do 1 times 4, which is 4 24ths. And 6 24ths and 4 24ths would be 10 24ths. But 10 24ths is exactly the same as 5 12ths, which is what we got earlier. Because if you half both of those numbers, half of 10 is 5, half of 24 is 12. So whichever answer you give is the same because it is equivalent. 5 12ths and 10 24ths are equivalent fractions. Question 7. The denominators are 3 and 8. Now you can't just double 3 to get 8, because double 3 is 6. And you can't triple the 3 to get 8, because triple 3 is 9. So an easy way to find a common denominator is to times the two denominators together. So 3 times 8 is 24. So a denominator of 24 would work. So we'll turn both fractions into 24ths. To get from 3 to 24 is times 8. So 2 times 8 as well on the top is 16. So that one is 16 24ths. To get from 8 to 24 is times 3. So you must do exactly the same on the top. So 1 times 3 is 3. So that's 3 24ths. Now we've made some equivalent fractions. We no longer need the original numbers, which were 2/3 and 1/8. We just need the new fractions, which are 16 24ths, take away 3 24ths, which is like saying 16 goldfish, take away 3 goldfish, would be 13 goldfish, where the unit being goldfish. So 16 24ths, take away 3 24ths is 13 24ths, where the unit is 24ths. And that's your final answer, 13 24ths. Question 10, we're looking for a common denominator that both 6 and 5 will go into. If you can't spot it straight away, just do 6 times 5, which is 30, and 30 will be a common denominator. So if we make 6 into 30, that's going to be times 5. So do the same on the top. 5 times 5 is 25. And to change 5 into 30, that's times 6. So do the same on the top, times 6. 3 times 6 is 18. Now we've got some equivalent fractions, we no longer need the original numbers. So we're dealing with 25 30ths, take away 18 30ths. Now if we think about lollipops, 25 lollipops, take away 18 lollipops, would be 7 lollipops, where the unit is lollipops. So 25 30ths, take away 18 30ths, is going to be 7 30ths, where the unit is 30ths. Final answer to that one, 7 30ths. Question number 11. We need a common denominator for 6 and 7. Well, if you can't spot it, you can just do 6 times 7. 6 times 7 is 42. So a common denominator would be 42. Let's make them both out of 42. To get from 6 to 42 times 7, so you need to do exactly the same on the top. 2 times 7 is 14. That gives us 14 over 42. And to get from 7 to 42 times 6, do exactly the same on the top. 3 times 6. 3 times 6 is 18. So that one is 18 over 42. Add the two together. It's like saying 14 chips plus 18 chips would be 32 chips, where the unit is chips. So 14 42ths plus 18 42ths is 32 42ths, where the unit is 42ths. 32 over 42 would actually simplify. That is a correct answer. You could give that in the exam, but both of these will half, so we can have 16 over 21. So 16 over 21 is also an equivalent fraction that you could have as your answer. Okay, and the last one. We've got 8 tenths plus 8 ninths. So what we need to do is find the common denominator for tenths and ninths. If you can't see one, you can just times them together. 10 times 9 is 90, so 90 would be a common denominator. Make that one out of 90, make that one out of 90, and see what you need to do to get there. To get from 10 to 90 is times 9, so we need to do 8 times 9 on the top. 8 times 9 is 72, so we've got 72 90ths, and to get from 9 to 90 is times 10, so you need to do exactly the same on the top. 8 times 10 is 80, so we've got 80 90ths. So you've got 72 90ths plus 80 90ths. It's like saying 72 oranges plus 80 oranges. Well, 72 plus 80, 70 plus 80 is 150. So 72 plus 80 will be 152. So we'd have 152 oranges, but seeing as this is dealing with 90ths, it's going to be 152 90ths. Final answer, 152 90ths. If you did want to convert it into a mixed number, you'd have to do 152 divided by 90. And obviously, one lot of 90 would go into that. And to get back up from 90 to 152, you need an extra 10 to take you to 100 and an extra 52 to take you to 152. So 10 plus the 52 is 62. So it's 1 and remainder 62. And because we're dealing with 90ths, it's 1 and 62 90ths. Final answer, 152 90ths or 1 and 62 90ths. Now we've had a go at those questions, it's your turn to go back and look at the ones that we've missed. Good luck.